Okay, Unit 7 is about polynomials and power functions. So we're going to talk briefly about polynomials here. And sometimes it's easier to think of what a polynomial is or isn't instead of just defining it. Here's some examples. This is a polynomial, 2x to the third plus 5x squared plus 8. In fact, that is a trinomial because it has 3 terms in it. Another example of a polynomial would be, let's say, 6x minus 12. And that's an example of a binomial because it has 2 terms. So this one up here is a polynomial. This one here is a polynomial. Let me give an example of one that is not. This is not a polynomial. 8x to the third plus 2x to the negative 2. That is not a polynomial. And the reason that that one is not is because of the exponent right here, and that is a negative exponent, and a polynomial can't have a negative exponent. Another example of one that is not would be 6 x to the 1/2 power plus 3x. That one also is not, and you can probably tell why here. You're not allowed to have a fraction in the exponent up here, so that one's a no. Then there's one other that comes to mind that's a no right away, and that would be something like 4x to the y. That one is not because it has a variable in the exponent. So that one is also a no. Okay, so anytime you have a negative, a fraction, or a letter in the exponent, those are not polynomials. Okay, if at any time as we're doing this, if this goes too fast, go ahead and just pause it, but make sure you write down everything that you see here in these notes. At the end, you're going to be asked some questions. Alright, so the next term we need to define is the term terms. And you saw this a little bit when you did your function sorting activity. And a term is separated by plus or minus signs. Plus or minus signs are terms. So for example, this 6xy plus 3x minus 4, that has 3 terms. This is a term, this is a term, and this is a term. If it has 3 terms, we call that a trinomial. So in this one, there are 3 terms. And one other example here, because these are pretty simple, would be 7x to the 4th minus 8x squared y plus 3y minus 15. You can see that one has 4 terms in it. We call that a quartic. And there's a term, there is, and there is. So they're just separated by pluses or minuses. Terms are pretty straightforward. Okay, the next definition that we need are the 3 types of polynomials we're going to deal with the most are monomials, binomials and trinomials. A monomial has one term. A binomial has two terms. And a trinomial has three terms. Okay, and you should know that by the prefix here, mono, like monopoly, one, bi, like bicycle, two wheels on a bicycle, and tri, like triangle, is three. Okay, for our next one then, we need to talk about degree. When we talk about the degree of a polynomial, we're talking about the largest sum of exponents in any term. Largest sum of exponents in any term of a polynomial. I think this one it's easier to give you a couple examples here probably. So for example, 6x to the third y to the second plus 4x to the, let's say, fourth minus 8. You might be asked the question, what is the degree of this? Well, to find the degree, we take the exponents of any term. So here's a term, here's a term, and here's a term. And we look at the exponents. So we have this right here, 3 and 2. And 3 and 2, that one would be 5, would be the degree of that term. This one we only have a 4, so the degree for this term would be 4. And this one there's no variable or exponent. If you don't see a variable, then the degree is 0. Right? Well, we look at the biggest one, and you can see the biggest one is the 5. So this is a polynomial of degree 5. You look at the biggest one. Okay, here's one more example that we can do. Negative 18, a to the third, b to the fourth, plus 7, a to the fifth, b, minus 6b. Let's look at that one and see if we can figure out the degree of this polynomial. Well, again, we look at the exponents, and we've got the 3 and the 4, so together that will give us a 7 for the degree of that one. This one's a little tricky. There's a 5 here. You don't see anything here, but there's really a 1 there. So this will give us a degree of 6, because you do the 5 and the 1. This one right here, again, we don't see any exponent for the variable, but there's really a 1 there. So that will give us a degree of 1. So when we look at all those, the biggest one is the 7. So the degree of this polynomial is 7. Okay, there's two other things we need to talk about here. And one of them is something called descending exponential order. And this is just the proper way to write a polynomial in descending exponential order. Okay, it's where we reorder the terms from the largest degree to the smallest degree. So for example, if this was a polynomial, 8x to the second plus 3x to the third minus 8x, let's make that 18x so it's a little easier to differentiate, and then plus 4x to the fourth. And let's put that in descending exponential order. The way we do it is we'd put it in order from the biggest exponent to the smallest. So we'd start with a 4x to the fourth. That should go first. Our next one would be plus 3x to the third. Our next one would be 8x squared. And our last one would be minus 18x. This is the proper way to write this function. That's descending exponential order. You start with the biggest exponent and they cascade down. They work their way down to the very end. Okay, one other example here. 6x plus 3x to the fifth minus 4. Pretty easy to see what the biggest exponent is, 3x to the fifth. Remember, this one right here really has a 1 on it, so that's going to be next, plus 6x, and then any constant you have, this minus 4, will just get tacked on to the end. This is written in descending exponential order. Okay, our very last one here is a leading coefficient. Leading coefficient. Okay, leading coefficient. It is the coefficient in the front of the polynomial as long as the polynomial is written in descending exponential order. So for example, if we had this 4x to the second plus 5x minus 12x to the third. Well, first we have to make sure it's in descending exponential order, and this one is not, so we need to move things around. Negative 12x to the third plus 4x squared plus 5x. Now this is in descending exponential order. Now we can see what the leading coefficient is. It's the coefficient in the very front. The leading coefficient for this one is negative 12, and just negative 12. Okay, now that you've taken those notes, you should be able to do these 6 problems right here. So the next thing you need to do is you need to do these 6. Make sure you write number 1, 2, 3, 4, 5, 6 in your note section for 7.1, and then do these 6 questions. As soon as you are done, then you are ready for the Act 2 activity for Learning Target 7.1.